Hi all, myself Pranjal Bhatt, and today's session will be on data science in Intellicus. This session will be focused on how we can do data science operations like training, testing, validating, deploying the model, and reporting on the same on in Intellicus. So a prerequisite for today's session would be one should have some knowledge of a basic knowledge of data science concept, like what is training data, what is testing data, what is a model, and some knowledge of Python will also be a plus. So starting with the agenda, so we'll first be looking at a very small introduction of data science. So what is data science? We'll be looking at. Then we will see how we can configure data science connection in Intellicus. Then we'll be solving a very small predictive analysis use case at a query object level, and then we'll be creating a report on that. There will then be a last use case would be on predictive analysis at a report level. So predictive analysis at report level is also what if analysis, and then we'll be moving to the Q&A. You can also post your questions in the Q&A section, and our panelists will be able to answer that. Moving to the first part, a small introduction to data science. So data science is basically extracting useful information from data. So anything that involves with machine learning, AI process, or data analysis and data analytics, everything comes under the umbrella of data science. To talk about machine learning in particular, so machine learning is where we are training a model on our historical data, on some labeled data, and we are then using that model to predict on the unknown data set. If you talk about data analytics, that does not involve training the data, but it has some statistical inferences drawn out from the data set or some descriptive analysis from the data. That would be data analytics. So all this comes under the umbrella of data science. So little bit more on the machine learning. So there are majorly three types in machine learning. One is supervised, unsupervised, and reinforcement learning. In case of supervised learning, the data is divided into X and Y variables, also independent and dependent variables. And then model, so data is labeled in case of supervised learning. And the models are trained on this labeled data, and then using this trained model, we do the prediction on the unknown data. One example for this would be a loan defaulter use case where a bank would try to predict whether someone would default a loan or not based on certain attributes like the salary or the CIBIL score or the employment type of that person. So here the data is labeled as a defaulter being yes or no. So this is a case of supervised learning. In case of unsupervised learning, we don't have labeled data. We just have X variables or independent variables. And what we do with this X variables or independent variable is that we group these variables. We group them into clusters. This is also called clustering, and then we draw insights using this grouping. For example, this grouping is also done basis on the similarity of the data points. One of the example of this could be a customer segmentation use case, where a retail store would want to cluster its customers basis a good customer or a bad customer. So they would find out the similarity between a good customer and they would group them. And then that would be useful for them in giving them the discount offers and everything. So this is one example of unsupervised learning. Another could be a Netflix recommendation engine where if you're watching a movie, it would recommend you the most similar movie to the one you're watching. Going to reinforcement learning. So this is where machine learns by making multiple trials and correcting itself based on set of rules of positive and negative reinforcement. So here machine will perform multiple iterations on itself, and it would basis these iterations, it would have a positive and negative outcome, and using that outcome, it will decide the next move. So this is reinforcement learning. So the example of this would be a self-driving car or a game bot. So little bit more on the supervised learning. There are two types in supervised learning, again, a regression and a classification. Regression use case is where you will have the target variable or independent variable are continuous numbers and not the classes or the labels. Uh, so if you are trying to predict the sales of a store, that would be a regression use case, because sales could be anything from zero to infinite, right? Uh, a classification use case is where you have limited number of outcomes. For example, the lone defaulter that we have discussed, where you only have two outcomes, yes and no. So this is the classification of the supervised learning once again. Okay. So this completes the first agenda that we had today, which was introduction to data science, a small introduction to data science. Now we'll be moving to how we can configure data science connections on Intellicus. So Intellicus comes up with Intellicus provides you facilitates you and provides connectivity with the languages like R and Python. For each of these language, Intellicus has its own library which you can install, and you can perform all your data science operations in Python or R, any of these language of your choice, and you can perform and you can train your model and deploy and use it for reporting. Okay, so anything that can be done through these languages can also be done in Intellicus. What are the steps for to make a data science connection? So then first step would be to install relevant library, be it Python or be it R, then making some configurations, and then create a connection in Intellicus, and you can start your machine learning task. In this particular session, I'll be focusing on the connectivity of Intellicus with Python. So for this, we have Intellicus has its own library, which is Intellicus Py. So Intellicus Py enables a user to connect Intellicus application with Python. Python could be on the same server where Intellicus is running, or it can be on another server also. So all your connections, data connections that you have made in Intellicus and your data sources which are available in Intellicus can be utilized directly in a query object, and the data can be sent to the Python, then we can utilize the power of Python to perform the machine learning operation, and then we can push this data to the database, or we can directly use this for the reporting. Okay. Then we'll move to the steps how we can configure Intellicus Py in Intellicus Py in Intellicus, or make a data science connection using Python in Intellicus. So the first step would be to install this library. So we have this simple pip install command that we can run the command prompt. So this will install the library in your Python installation path. Okay. Then there is a property file. So there is a JSON property file that you can make changes in this file, and basically this will tell the Python how much which port do you want to start this service on, or what are the number of parallel threads that this service will utilize. So this property file one can configure, and then this will be used for before we have to start the Intellicus Py service, we will have to configure this property file. Then we'll have to tell Intellicus where this property file is kept. So we will be providing the path of this property file to this Intellicus Py library. After this, we will start the service, the Intellicus Py service, and then we will make a connection in Intellicus, and then we can perform the data science task. So these are the steps. So I will be showcasing all these steps one by one. So I'll just copy the first command from here. I'll open the command prompt, and I'll be pasting this command here, and I'll run this. So in my machine, this is already installed. Intellicus Py is already installed. That's why it won't take much time. There are just few libraries which it will install. Otherwise, all other libraries are there. Okay, so this library is now installed. After this installation, we will be moving to the folder where this is kept. So where this library is will be there. So you can see that the path where Python is there. So in my case, the Python is there in the Anaconda folder. In your case, you'll have to find out where the Python is present, and inside that Python file, you will be able to locate the lib and side packages folder, and inside that you will find the IntelliQuest file library. So here there are two ways. I was talking about this IntelliQuest file, which you have to use for configurations. So let me open this file and show the configurations. Okay, so here is the content of IntelliQuest file. So first is port. Port is where this IntelliQuest service will be running. So for example, in my case, it is 45460. So by default, it is 45460, and you can leave it as it is. Log level is debug. So debug is where all the logs will be generated. This could be error also. So in case of error, only if you see any error, then only the logs will be generated. Log path. So you will have to mention the one particular folder in your machine, and there the log file will be generated. So you can mention that here in the log path. Max client is the maximum number of threads. So for example, right now there are 10 threads, meaning that there are 10 Python jobs that can run in parallel. If you can increase it, if your machine has higher configuration, you can increase it to 15, 20 also. Request timeout is 600, meaning that if all the threads are occupied and there is a new Python job that got submitted, it would wait up to 600 seconds before exiting. If it is not able to find a thread before 600 seconds, it would simply fail the program. Then flake-it errors to consider. This is again, you can leave it as it is. Flake-it is basically a library which will validate your code that you have written, that is standard in a standard format or not. For example, if you have imported a library and you have not used the library, then it would throw you an error that you have imported this but you have not used this. So this is one of the scenarios that I've just told. So there could be many scenarios. So you can just leave it as it is. Encryption key also you can leave as it is. This is just to encrypt your data for security purpose. Then load model while startup. So this is important. So if you have some pre-trained model that you want to use, and you don't want to train your model at runtime, but you want to use some pre-trained model. So in that case, you can set this property as true. Model load info. So once you set this property, load models will start up as true, then you will have to mention this model load info. So here you have load model directory where you will be specifying the directory where your models are, pre-trained models are kept. The name of the model you will be specifying then, and load all models. So if there are multiple models in that folder, you will be mentioning this as true. So if you want to use more than one model. Module name pickle means pickle is generally used to serialize and deserialize your model. So so module name pickle. So if you have serialized your model using this pickle module, then you will be mentioning the pickle module here. Okay, so you can set all these properties. After setting all these properties in the property file, this property file is available in the IntelliQuest documentation page online, and this will also be attached in the PPT that I'll be sharing. So you can find this. You can also contact the support team for the file if required. So this will be available to you. I'll close this. And now we will have to tell this library that where this file is kept. So basically, I've kept this file in the same folder where this library is present, but it could be anywhere in the installation directory. So I have this run pyserv.py file with me. So I'll just edit this file. Just give me a minute. Okay. So this is the content of run pyserv.py file. So here I will have to specify the path of this property file, IntelliQuest file or property file that we have configured previously. So after doing this, I'll just save this in run pyserv.py and then we are ready to start our Intellicus Spy service. So to start, there are again two methods. One is you can simply go to this bin folder and you can double click on the start intellicuspy.bat file. So for Windows, this is the bat file. For Linux, you will have a .sh file that you will be using. This is one method. But in case you have multiple Python environment in your system and you want to specifically start the Intellicus Spy service in a particular Python environment, you can open the command prompt. And for example, my Python environment is in D Anaconda folder, Python. So I can specify the path of that environment, and simply I can then uh, select this run PySub file and press enter. So this will also start my Intellicus Spy service. Now the Intellicus Spy service is started after making all the configurations, and then we are ready to make a connection in Intellicus. So I'll be moving to the Intellicus portal now. Okay. So this is the Intellicus portal. I have just logged in this portal, and I'll be going to the configure page. I already have a connection. I'll delete this connection and I'll just recreate it. So I'll click on add, and in the provider name, I'll be going to the data science engine, and then I'll be selecting this option here. Okay. So in the platform, I'll see two options: RServe and PyServe. I'll be selecting this Python option. Server will be, since the Python is also running, Intellicus Spy is also running on my local machine, so that's why it is 127.0.0.1. In your case, if the Python is running on some other server which is in your network, so you can mention the IP of that server. Port we have already seen, it is 45460. Dump connection name is used for in case so there are some temporary files that Python generates while creating the report while running the Python code. So dump connection name is also necessary. By default, it is demo file source. You can leave it as it is. You don't have to change it. If you want to change it, for example, in my case, I'll change it to PyDump. You can change that also. So after making this change, you simply click on test. So the connection has passed, and you can click on save. So now the Python connection is saved. So this covers our second part of the agenda, which was configuring data science connection in Intellicus. Now we will be moving to a small predictive analysis use case at a query object level, right? So now we are basically ready to perform all the data science operations in Intellicus. Okay. So now if I just go to design query object. So in the left panel, now there is an additional option which will appear, which is data science engine. This option will only be there if you have successfully configured the PyServe connection. Otherwise, this will not be there. So we have this option now. So now what I'll do is, so I'll solve a very simple use case of lone defaulter prediction only. So you have data source step here. You could have any connection of any database. For example, you can have a connection of SQL Server or an Oracle or any big data source. So you can have any kind of connection. You will have to just drag the data source from here. Right now, I'll be using the demo file source only. So I have a file-based connection, and I have a particular file right now which I'll be using. So I have this training file. So I have training data. I'll select this file. I'll click on results. So you can see that it is a simple use case of a lone defaulter where there is a risk flag involved, whether someone has defaulted or a risk, someone is a risky person to lend a loan or not. So these are the attributes of the historical data and of the person, of the customer basically. So the income, age, experience, marital status, house ownership, car ownership, profession, city, state. So all these are attributes, and using these attributes, we will do the prediction of risk. I'll click on OK. So the training data is now selected. I'll drag this. I'll now select the testing data. So I'll again go to demo file source. And again, I will select, there is a separate file for test data. I'll select this and I'll click on OK. I'll drag the data science engine step in the middle and I'll join the test data with this. All right. So now my data science engine is utilizing the training data and testing data. Basically, the model will be trained on this particular data, and then the trained model will then be utilized to do the prediction on the testing data. This is not a necessity to give that this particular name only. You can give any name. So, for example, I can just remove the data and simply give a training. Here I can again remove the data. So, and you can give any name. Okay. So the next step is to configure our data science script. So Intellicus comes up with this low code, no code kind of helper utility, which enables a business user also to create a data science script, or a data scientist to create an initial data science script, which he or she can then change or make changes, fine tune, and then further use. So here you will see multiple options. You have training data source here. So here we will be selecting training only, since we have two data sources, which is training and test. So I'll just select training in the training data source. Prediction, so we'll be predicting on test data. So I'll select test here. Target variable, so which variable do I want to predict? So in my case, this is the risk flag variable I will be predicting. So I'll select the risk flag here. Best fit model. So I have this previously available models with me. So I can select any of them. For example, I'll select random forest model for now. It is going to show you some hyperparameters which you can change as per your choice. And then we have this output data. So the output data for reporting purpose, if you only want to save your testing data and not the entire data set involving the training and testing, you can set this as prediction data only. If you want to append your training data with the predicted data, then you can select the second option. I will just be selecting the prediction data only option right now. So this is done. After this, we will then be selecting the independent. So target variable is now set. We will now select the independent variables or X variables. So I can select, I will select income, age, experience, marital status, house ownership, all that I have selected. Some profession, city I'll not be selecting. So this is just an example. So I've selected 5, 6 variables. Here I have data substitution option where the null values of the data will be substituted with mean, median. So all the options are given here. So if you want to substitute your the null values with the mean, median, most, midpoint, or constant, you select constant here. It will again give you and this option to enter your value. You can enter your value here, and the null values will be substituted by that. So these are the options you get. So as soon as you configure all these options, you can then click on edit. Just a minute. Let me just relog in. Okay. So probably this session was going on from a long time. So I have again clicked on some variables and I have created this particular script now. Okay, so this script will be auto-generated as soon as you select all the options from there. This will be auto-generated. And this is not necessary that if you have to use this particular script only. You can make changes in that script. So if you want, for example, this is where I am defining the model where I could include other hyperparameters also. So I can change this script, and I can change this particular script and then use it accordingly for my use case. So let me just give you a brief on what this script is, how this script is generated, and how what sections that does it have. So you can see that there is a training section here, and then there is a prediction section also here. Okay. So in training, so consider these two sections as two different Python scripts altogether. So one is training script and another is prediction script. So you have an option to run these two scripts separately also or combined also. So at a time you can train your data and do the prediction, or just do the prediction using the trained models. So that option is also available. I'll show you both the options, but let's go through the script one by one. So initially the models are imported here, and then the first after importing all the libraries, not the models, after importing all the libraries, then the first step is to read the data set. So you have mentioned here training data, the same name you have to give here along with this dot data operator. So this is the Intellicus specific syntax. So you have to mention this training data here and dot data, and then this operator. So basically what this will do is it's going to read the data whatever there in this particular data source. So right now it's a file-based source. It could be anything. It could be a SQL Server connection or a Oracle connection. It could be anything, but the syntax would remain as it is. The syntax would be pd.read CSV and then the name of this source. Right. So since this is the training section, we have only read the training data. Now these are the X columns that we have selected in the design mode, and the Y columns is the ID column. Okay, so I have selected ID. Let me just change it to this flag. Okay. So I have now my target variable is a risk flag that I have selected. After this, so imputer, so whichever the way we have done the configuration, for example, we want to replace the null values with the mean or the most frequent value. Similar to that, the imputer functions will be called. So this is the imputer section. Then there will be encoding also, which will be done. So you will have a label encoder in place, and one hot encoding will also be done on your data set. And all this encoding will also be saved for the later use. Then there will be scaling done. So all this will be done by Intellicus. All the code will be generated by Intellicus. You can basically use this particular code. You can copy this code in a Jupyter notebook or some other IDE also, and you can edit this code and then redeploy the code, this particular code in Intellicus. That also can be done. Okay. So after performing all these operations, then the model is defined here, and then we have trained the model in this way. Okay. Then this step is also important. This is where we are serializing the imputer, scalars, and model objects. So this is important because I have told you that training section and prediction section, since they are different, that they will be considered as a two separate Python code. And if you want to use all the trained objects of label encoder and one-hot encoder in your prediction part, you will have to dump them in a temporary location. So this code will dump all these objects in a temporary location. And in the prediction section, we will again be importing all the libraries. Then we will be reading the data set again in the prediction part. So in the design, I will have to use testing, so that the scripts will be generated accordingly. Yeah. So the test data, so we will be reading the test data now. And again, similarly, we have defined the X columns. So here we are loading all the objects that we have saved in the in this training section. So we will be loading the imputer objects here. Then we will be loading the label encoders, standard scalar, and my model. So all this will be loaded, and then they will be used for prediction. So here we are doing the prediction, and then this is saved in this particular. The prediction will be saved in this column, and this will be assigned to one of the column in the testing file. Okay. So this is done, and after this, the last step is also important, where my final data frame, which is X list. So this is my final prediction, and this prediction I can then directly use for reporting, or I can save it somewhere in the using the load step. I can then save it somewhere. So how will I move this data frame to the next step? So next step right now is a format step here. This could be a load step also or a format step also. Format step is when we directly want to do the reporting. We'll be using the format step. If we want to save our prediction in a database, then we will be using the load step here. So this is what this step.data, this keyword is going to do, is that it's going to move this Express data frame to the next step, which is right now a format step. So all this automatic script generation is helpful for a business user or a machine learning user initially to create a code and then make some changes and probably fine tune their code, redeploy in Intelligence, and utilize that for the reporting. So right now, this takes good amount of time for training and prediction. So I have prepared a use case on the sample data set. So I've prepared this QO loan defaulter query object, where I've just read the same data. I have training data and testing data that I have used in this QO and data science script. I've just edited this script. So this is the same script that we have discussed, just that I have just taken a few sample professions so that the script runs a little faster. Okay, so it's the same script. So what I'll do is now I'll simply verify this particular script. It would take few seconds to train the model and do the prediction. Okay, so you can see that the script is now verified. I'll click on results, and you can see the prediction has now been done. So this is the risk flag prediction. It's basically showing you a continuous decimal values, because we have calculated the probability of a person uh, to be a defaulter or not. So that's why it's showing. So you can basically assign, if a value is greater than 0.5, it would be 1, and if a value is less than 0.5, it would be 0. So that you can do. So this is now calculated. I'll click on OK. So we are ready with the query object now. So now we can create a report on this query object. So I have created a report already on this. It's a simple grid report. And this is defaulter analysis. I run this report. This is going to execute the query objects at the background and going to generate the output. So before running the report, as I've told you, there were two sections in the query object, which are training section and prediction section. So while running the report, it would again ask you if you want to do the training and prediction or prediction only. So since I'm running this for the first time, I'll be selecting the training and prediction option, and I'll click on run now. Okay. So this report is now generated. It's a simple ad hoc report. What I want to show you is this option. So right now it took around 1 minute to train the model and load the report. But if you don't want to train the model again every time, and if you only want to do the prediction, then that option is also available. So if I select this prediction only option, it's not going to train the model. It's going to utilize the trained model object that we have saved in the temporary location, and it's only going to do the prediction only option. You might have some other reporting filter along with it. So if you want to, slice and rice using those filters, and you don't want to do the training again and again, then you can select the prediction only option. and then apply the other filters, do slicing and dicing in your data set. That way it would be much faster. So I'll select this prediction only option and click on run now. So you can see that this time it has loaded fast. Okay. Okay. So this completes our fourth part also, where we have created a report on the query object level. We will now be moving to the predictive analysis at a report level. So this is also called what if analysis. So this is useful in case if you want to do some kind of decision making for your business and you want to utilize the power of machine learning for that kind of decision making. For example, so if there is some target that you want to achieve, and you want to change certain attributes, and you want to see that by changing these attributes, at what scale do I have to change this to achieve that particular target? So for this kind of scenarios, we use what if analysis. So again, I'll be showcasing one small example on this. Okay. So for this, we will directly be creating a report. So I have this. So before that, we'll have to prepare the query objects. So you should have two query objects available. So I have QO what if analysis, which I just opened, and you can see that in this particular use case is where we are finding out what is my order completion percentage. So I click on results. So you can see this is the date. Then you have total number of orders booked, delivered orders, then delivery person count, average time to deliver the order, then order completion percentage, and then average time to ship. So using all these attributes, we'll be calculating the order completion percentage. And if we have a criteria that our order completion percentage should be above 90, then we'll have to make changes in the other attributes. And by making these changes, we will be achieving a target of 90% order completion. So this is my training query object, and I have a similar testing or a prediction query object available. So here also I have similar columns, just that here the total order completion percentage, only the column is there, and we have all the null values here. All right. So for this, we will be creating a smart view report, and we in the smart view report we will be selecting the first query object, QO what if analysis, and we can click on select here. I'll add a chart. I'll add date value here. I will in the Y. I will simply drag the order completion and click on apply. So in the date, I'll select date and apply. Okay, so these are my historical data for my order completion for each day. So if you want to make a prediction now, click on this prediction option, and all the options will be available. All the columns will be available here. So whichever column I want to predict, for example, I want to make a prediction on order completion percentage. So I will be clicking on this particular option, and then again, similar to the one that we have in the query object, we have all the options here. So order booked, I'll be selecting, then delivery person count I can select, and data substitute the function. So this is important here. So since this report is running on this QO or this ML operation is we are doing at a reporting level, so we will require a aggregation function. So here the machine learning operation will take place on an aggregated data and not on the raw data. So this is very use case specific. It does not fill all the requirements, but if a use case demands, we can use the what if analysis in IntelliPlace. Right. So I'll select the order book delivery person count, and I can therefore aggregated function, I'll keep it as it is. The data substitution also I'll keep as it is. And learning algorithm, I can select random forest for now. Okay. Again, here there are multiple options. So here we have an auto option and a data source option. So what auto option will do is that in case of auto, we'll have to provide the number of data points. So if I selected auto and mention 10 data points here, it's going to do the prediction in the future for 10 data points. This is required in case my prediction data or test data is not available with me. But since the prediction data is available, so in case of so instead of auto, I can select the data source. And data source, I'll be selecting the prediction data, and uh, I'll select this and click on edit. So again, the query similar to the one that we have seen will be generated here. So here there will be again training section, prediction section, and there will be additional meta section also. So in the meta section, since we have only selected two columns for the prediction, so these two columns will be measured, and we have taken the summation of these two columns. So this will be there in the meta section. Sum of order booked and sum of delivery person. And then the training section is similar, uh, where we have imputed all the values. We have done the standard. We have used the standard scaler. We have initialized the model, and then we have fitted the model. And then we'll be dumping this all this train model and label imputers in a temporary location, and then we will be then the prediction section would start. So in the prediction section, again, I'll be importing the library, then reading the data, and doing all that imputation and doing the prediction. So this is how you can do the what if analysis at a reporting level. Now this again takes some time for the training and everything to happen. So I've prepared a report on this just to showcase how what if analysis work. So you load the report of the same use case in the screen now. So you can see that this is the report that we have generated. So similarly for the similar use case. So you have we have used all the orders booked, order delivered, all the columns here for the what if analysis. And so let me just tell you how this looks. So if you click on this edit section, so I have multiple measures here, y1, y2, and the order completion percentage is something that will be predicting. So so the solid bars that you see, this is the historical data. So 12/31/2022, this is where till when I have my historical data available. And this dotted lines, this is my prediction. Okay, so this will be generated using that data science script that we have written. Now, what I can do with the what if analysis is that I can change my X attributes. So in the dotted section of the prediction part, you can see that most of my bars are red, meaning that I have not achieved my 90% target of order completion. So if you just hover over this, so you can see that order completion is 88%. If you just hover on the green bar, so you can see this 90%. But on other days, I've not achieved my target. So what should I do in case I want to achieve my target? So for that, I'll be going to the filters and I'll click on what if. Okay. So in the what if, I can see multiple options here. I can scale up and scale down or increase or decrease this or these options to achieve my target, to see how can I achieve my target basically. So for example, so whatever delivery person that I have, I've already increased it to 40%. Let me see what would happen if I increase it further to 50%. Average time to ship. So average, if I reduce this by 20%, will it impact my service level? Okay, average time to ship and average time to deliver also I'll reduce by 10%. Right, I click on apply. Let me just reload this. Okay, let's see here itself. So I have selected all the columns and I'll click on OK. And this will run the data science script at the backend and it is going to generate the prediction. Okay, so now what I can do is I can go to this filter options, I can go to the what if options, and I can then increase or decrease these options. So let me load the older report first. Okay, so now I can go to my what if section here. I will increase the delivery person count to 25%. I can reduce the average time to ship and average time to deliver, and I can click on it. So you can see that now most of my bars are green, and I am able to achieve my target for most of the days, right? So this is how you can perform what if analysis for decision making in your business. So this is a type of use case that can be solved using what if analysis. This completes the last part also for our agenda today, which is predictive analysis at a report level. There is just one more point I would like to cover before closing this. So we have seen that in the query object level, we can generate the script, Python script for our use case, and then accordingly use that for the prediction. If we already have a script that we want to use and do not want to use the Intellicus generated script, that also can be done. So a bare minimum requirement for Intellicus to run your Python script is that so you should be mentioning this particular data source. We should be reading the data from this particular data source, and you will be writing your data to the next step. So what I will do is I'll remove everything from here. I'll remove training section. I'll just import the pandas library. Then I'll be reading the data from the previous step from the training data, and I'll remove everything else. Okay, so I only have this 3 line of code now, and the same data frame that we have read from the previous step, I will be then pushing this data frame to the next step. So this is the bare minimum requirement that you should follow while writing your Python script in Intellicus. Then all your ETL operations can be done here. ETL operations or ML operations or AI operations. So all that can be done in the step between these two. So you can do everything here, and you can generate your final data frame. And after generating the final data frame, you can push this data frame to the next step. So I'll click on verify. So what it will do is it would simply read the data from this particular training data step, and it would use that particular data frame for the next step, which is the format step right now. So in case your data size is large, what you can do is there's one more option available. So in case your data is huge, for example, the way I have right now, there's one more option you can use. Okay. So you can edit this. and then there is a rows of verification option. So right now it is set to 1 lakh, so you can reduce it to 10 or 100. So if you only want to run this particular verification step for a very limited number of rows, and don't want to run this for your entire data, you can simply mention it as 10 or 100 and click on verify then. So it will simply run this for few rows and then it would show you the results. So that also can be done. Right, so it is verified now, you can see the results. Okay, so this completes our agenda for today, which was data science in Intellicus. Uh, thank you for your cooperation and being a good listener. I'll be closing the presentation now. Thank you.